With dividing radicals and what we're going to call rationalizing denominators, we're now going to work with radicals within fractions. So first off, we have a quotient rule, which really just says the idea that we can have division. If I have a radical divided by a radical, assuming they are the same index, I can rewrite that as the fraction within the radical. Now this will help us in a couple ways. If they start out as separate radicals and I think of them as one, I could simplify this fraction and then apply the rules that we have for radicals. The other way is maybe it couldn't be simplified, but it is a fraction. You can split it and simplify further. So we're going to work between these two kind of modes to allow us to simplify. The other thing we have is rationalizing a denominator. We cannot leave a radical in the denominator. So anytime that comes up, we're going to multiply the numerator and denominator by a radical in that denominator to make a set. So let's show what that really means. So 1 over the square root of a. I can't leave it as that because it's a radical in the denominator. Then we call that an irrational number, so we have to rationalize so it's no longer irrational. To do that, I'm going to find the easiest way to make a set. I could multiply a radical by itself, which now gives me the square root of a squared, which would eventually become a. But to do that, I'd have to multiply the top by the same value, because what this actually becomes, this is just 1. We're multiplying a value by 1, but changing the way we look at it, almost changing the lens that it appears so we can simplify it. So in this case, it becomes the square root of a, and our answer is now the square root of a over a. So a basic example of this, if I said 1 over the square root of 3, I'd multiply the top and the bottom by the square root of 3. That gives us the square root of 9 on the bottom, the square root of 3 at the top, which becomes the square root of 3 over 3. We've moved the radical up in what we call rationalizing. So what if I have a radical on the top and the bottom? Well, I'm still focused on the one in the denominator. I can have a radical in the numerator. That's perfectly fine. But what's going to happen is it's going to be the square root of a times b over the square root of a squared. We then get the square root of a squared on the bottom, gives us an a, and it simplifies. So for example, square root of 2 over the square root of 3. Multiply the top and the bottom by the square root of 3. We then get the square root of 6 over the square root of 9. The square root of 6 over 3 is the rationalized version. So that rationalizing denominators it isn't its own type of problem in the set. It's more of a simplification we have to look for in the problem after we work through and do what we need to with radicals. So we start off with just a kind of simplifying a fraction. Separately, I could go in and try to simplify these two radicals and then look further. But what I would suggest doing is make them into one fraction first, because I can simplify within that fraction. 16 divided by 2 is going to give me 8. M to the 6 over m to the 3rd, well, there's 3 more on top, so that becomes m to the 3rd. So now, instead of having a fraction, we're now looking at it as the cube root of 8m to the 3rd. Just knowing we can work with fractions in that way and simplifying sometimes gets rid of the fractions and makes it a lot easier problem. Now we know 8 is 4 times 2, which is 2 and 2. So that's going to bring a 2 out. No radical left, no number left on the radical. Then m to the 3rd, it's a set of 3's, so that is 2m. So this whole thing simplified down to 2m by us simplifying the fraction first. Won't always be the case, but we look for that because it does make our process easier. Now the next one is where we have to look at simplifying a radical. Before I do that, let's simplify a little bit further, because we don't want to necessarily always have to rationalize the denominator. If I had the square root of 12, I know that's 4 times 3, which gives me a set of 2's, and this would become 2 root 3. So I'm going to change this top value. So now it's 3 times 2 root 3 over 4 root 7. It now becomes 6 root 3 over 4 root 7. 6 and 4 I can reduce to become 3 root 3 over 2 root 7. I get to this point, I can't simplify any further. This is where we have to rationalize the denominator. I have a root 7 on the bottom. I need to get rid of it. So I'm going to multiply the top and the bottom by the square root of 7. This is going to give me 3 square root of 21 at the top, 3 times 7 in the radical. And on the bottom, it's 2 square root of 49. Now we did this because The square root of 49 is 7. 7 times 2 gives me 14, and that is my simplified answer. It is not good enough to leave a radical in the denominator. When you see that, you're going to follow the process, multiply the top and the bottom, and simplify down. Last thing I check, 21, if it could be simplified, it can't, so we're good there. And then 3 and 14 if they could be, but we're good at a final answer. So looking at some more. We have the cube root of 7x to the 5th over 64y to the 6th. In this case, I'm going to split these into two separate radicals. So I got cube root 7x to the 5th and cube root of 64y to the 6th. The top one doesn't look very nice. I could take a set of x's out and make that, x on the outside, cube root of 7x squared, but it's not looking very nice. The bottom, though, has some options. 64 is 16 times 4, 16 being 4 times 4. So I can actually take a set of 4's out here, write it on the outside. Y to the 6th is 2 sets of 3, so I have y squared on the outside. So now my answer is x cube root of 7x squared over 4y squared. It doesn't look very nice, but it is the simplified version. I've simplified the radicals entirely, and I don't have a radical in the denominator. So we're done. Okay, let's go to the next one, the fourth root of 32w. I'm going to write that on top, and then the fourth root of 81. Let's start with 81. 81 is 9 and 9, which then gives us 4 3's. So I got 3 in the denominator. 32 is 16 times 2, which gives us 4 and 4, and we get 5 2's. 5 2's and its fourth root means 1 2 comes out, 1 2 stays inside, and then w didn't have the pair. So our answer is 2 fourth root of 2w over 3. Now we have the square root of 8 over the square root of 15. I can't reduce that fraction, so we're going to go square root of 8 over square root of 15. Before I worry about rationalizing, I would always look to simplify the fraction where you can. Square root of 8 is 4 times 2, so that gives us 2 and 2. So this becomes 2 root 2 over square root of 15. Now, I've kind of simplified all that I can. I have to rationalize the denominator. So we're going to go 2 root 2 over the square root of 15 times the square root of 15 over the square root of 15. Really, we're multiplying the whole thing by 1, but we're rationalizing. It's going to become 2 root 30 over 15. Square root of 30 can't be simplified because that's 6 times 5. There's no perfect squares. There's no sets. 2 and 15 can't reduce, so that is our answer. Now, next one, I'm going to put this as one fraction. I got 28 a to the 5th over 3a. At first look, 28 and 3 aren't going to simplify, but a to the 5th over a does. So this becomes 28 a to the 4th over 3. I'm going to split them back up now and just kind of go back to where we started, 28 a to the 4th over the square root of 3, and I probably need to rationalize. But before I do that, I'm going to simplify 28. 28 is 4 and 7, so I could take out a set of 2's, leaves in a 7. I also have a to the 4th, which becomes a squared on the outside. So now when I rationalize the denominator, I'm going to multiply the top and the bottom by root 3. We get 2a squared square root of 21, it's 3 times 7, over 3. Moving down, we now have square root of 8 minus square root of 2 over square root of 2. Do not cross these out. Okay, it doesn't work that way. You have to simplify them. So I can simplify the square root of 8. Square root of 8, as we've talked about before, is 2 root 2 minus the square root of 2 over the square root of 2. So now, still looking at the numerator, if I have 2 root 2 minus what's like 1 root 2, that leaves me with root 2 over root 2 which gives us an answer of 1. Okay, that was nice. It's simplified. Let's see what the next one does. 3 root 2 plus root 6 over root 12. Well, first off, square root of 12, as we've talked about earlier here, probably on the previous page, square root of 12 became 2 root 3. So let's change this to 3 square root 2 plus root 6 over 2 square root 3. Can't do much yet, so I'm going to split these into two fractions. 3 root 2 over 2 root 3 plus square root of 6 over 2 root 3. I'm going to simplify them separately. So off to the side here, 3 root 2 over 2 root 3, I'm going to multiply top and bottom by root 3, and we get 3 root 6 over 2 times 3, which is 6. 3 and 6, that's going to become root 6 over 2. Now, square root of 6 over 2 root 3. This, I can take the 6 and the 3 and reduce them because they're radicals, and make this into the square root of 2 over 2. That's what we have here. Now, they have like denominators, different radicals. The last step, I'm going to combine them and make it the square root of 6 plus the square root of 2 over 2. Still can't combine them, but we've simplified down, we've reduced, and that is our answer.